In real life situations, the slope represents the rate of change. Okay, so that's not really changing from what we know it as, okay, but it's going to compare the change in one quantity with respect to the change in another. Okay, and the y-intercept represents the initial value. All right, so the m, that's my rate of change. A keyword that you'd be looking for in application problems is per. And this is going to often be our unit rate. And a unit rate is just a rate that has a denominator of 1. Okay, so an example is like minimum wage. You could have $8.25 per 1 hour. All right, the cost of gas, you could have $2.25 per 1 gallon. All right, so it's when you're comparing a quantity to another and then your denominator has that unit of a 1. Okay, and the b value, this is my initial value. This is my beginning. So the reason or the definitions of them, what they represent, don't really change from what we talked about in the previous video when we were just trying to graph the line. The b is where we start, the m is how we move, that's our rate of change. But in word problems, like example 2, Mr. Peel started 7 meters away from the motion detector. So this is his initial location. 2 seconds later, he was 3 meters away from the motion detector. Find the average rate of change in meters per second. If this rate continues, how far away is he after 1.4 seconds? 2 things we need to do here. All right, one of the points is 0, 7. This is my beginning. And then it says 2 seconds later, he was 3 meters away from the motion detector. So if I look at this graph, I'll see that that point's right there. So what is my rate of change? What's my slope? So I'm going to do m equals 3 minus 7, subtract the y's, over 2 minus 0, subtract the x's. It's going to be negative 4 over 2, which simplifies to give me negative 2 or negative 2 over 1. All right, so that rate of change is negative 2 meters per 1 second. Okay, you could also see that written as negative 2 meters per second. So this is my rate of change. Okay, now when it's asking for how far away was he after 1.4 seconds, we actually want to figure out what is the equation of this line. What equation represents this situation? So we start with y equals mx plus b. We know the slope, and guess what? We know the y-intercept. We know where this started. Okay, so the equation of this line is going to be y equals negative 2x plus 7. Okay, so if this rate were to continue on this entire linear function, on this linear segment, how far away is he after 1.4 seconds? Well, x is going to represent 1.4. I'm going to plug in seconds, and I'm going to get out a distance away that Mr. Peel is. So y equals negative 2 times 1.4 plus 7. Use my calculator. So negative 2 times 1.4, add 7, and I'll get y equals 4.2. So Mr. Peel is 4.2 seconds away. Or sorry, that's not right. My output represents the distance in meter. So Mr. Peel is 4.2 meters away from the motion detector at 1.4 seconds. So at 1.4 seconds, he's 4.2 meters away from the motion detector. Which makes sense. If I have this graph here, we won't always give you a graph, but 1.4 is right about here. So where do I get that out on my graph? That's about 4.2. All right, in the next video, we'll keep doing some application problems.